All right, today we're doing something pretty cool. We're going to take a climate prediction that's 30 years old, and we're going to put it to the test against 3 decades of actual, real-world data. Let's get right into it.
You know, this is the big question, isn't it? We have these super complex models that are trying to tell us what the world's going to look like in the future, but they're just predictions. How do we know if we can actually trust them? Well, it turns out the best way to know for sure was just to wait.
So, to answer that, we've got to hop in a time machine. We're heading back to the 1990s, a really foundational time for climate science, to dig up a very specific projection they made way back when.
I mean, just try to picture the tech back then. The computers had a tiny, tiny fraction of the power that's in your smartphone right now. So the climate models they were running were, by today's standards, pretty crude. And yet, even with that tech, scientists made a really bold long-term prediction.
So here's how the whole story played out. In the early 90s, we launched these new satellites that gave us our first truly global, really precise way to measure sea levels. Then, in 1996, the IPCC used that early data to publish a major projection. And now, here we are in 2024. That 30-year test is officially over, and we can finally go back and check their homework.
And this was it. This was the message in a bottle they sent us from the past. Their best guess was that the world's oceans would rise by about 8 centimeters. That's around 3 inches over the next 3 decades. A very specific, very testable number. Okay, so now let's fast forward to today and take a look at the actual evidence, the real data that's been gathered so carefully over those 30 years.
And we're not talking about a one-off measurement here. This is a continuous, unbroken stream of data. Satellites have been circling the globe, measuring the height of the ocean, day in and day out for 30 years straight. It's one of the most solid climate data sets we have, period.
And that data showed us something absolutely crucial. The rise isn't steady. NASA confirmed that the rate of rise has actually doubled. So the ocean isn't just getting higher, it's getting higher, faster, and faster.
So after all that meticulous measuring, what's the final number? What did really happen? The actual observed sea level rise comes in at about 9 centimeters. Now keep that original 8 centimeter prediction in your head, because here comes the showdown.
Okay, this is the moment of truth. We have the prediction from 1996, and we have the reality from 2024. Let's put them side by side. And there you have it. The projection from 1996 was about 8 centimeters. The observed reality in 2024, about 9 centimeters. I mean, that's remarkably close, especially when you remember the kind of computers they were working with back then.
And hey, it wasn't just me who was impressed. The scientists who actually ran this comparison were kind of stunned themselves. The lead author, Torbjorn Turnquist, basically said his team was amazed at how well these simple, early projections held up. It's a huge validation of the basic physics they built into those models decades ago.
But here's the thing about good science. It's not just about getting the final number right. It's about understanding all the little details. And while the result was incredible, it turns out those 1990s models didn't get everything perfect.
They kind of got the right answer for slightly the wrong reasons. The models, it turns out, were way off on one major piece of the climate puzzle.
And here's where it gets really interesting. The 1996 models underestimated how much melting ice sheets would contribute by more than 2 centimeters. So how on earth did they end up so close to the real number? Well, by pure coincidence, they also overestimated other things, and the two errors pretty much canceled each other out. It's wild.
So why they missed the mark on the ice sheets? Well, back then, science just didn't fully understand how warming ocean water could literally eat away at Antarctica's ice from underneath. And they also had no idea just how fast Greenland's glaciers would start sliding into the ocean. It just goes to show you how science is always learning, always refining.
So, what does this all mean? What's the big takeaway from this successful 30-year test for us right now? That's really the most important question.
The lead author really just says it perfectly. He says, look, this study is some of the best proof we have that our basic understanding of climate change isn't new. The core science has been solid for decades, and now it's passed a major real-world test.
So, let's just recap the big takeaways here. First, even the simple early climate models were shockingly accurate. Second, because those work so well, it should give us way more confidence in the incredibly sophisticated models we're using today. And finally, this is just a perfect picture of how science works. You're always learning, always getting better, always refining what you know.
And that leaves us with one last pretty heavy thought. We've just seen that the foundational science from 30 years ago, run on basic computers, held up incredibly well. So, When we look at the projections being made today, with supercomputers and decades of satellite data and a much, much deeper understanding of how our planet works, it really makes you think about what those models are trying to tell us about our future.